Good evening, Photon Wranglers. This will be, I think, the 6th time I've tried to shoot this video because I keep running down the process of Comet stacking and processing in Pixinsight, and then I go back and try to follow my own advice, and I fail. It is hard to get Pixinsight to remove the comets from the subs like it's supposed to. It's very slick when it works, but it's hard to get it to do it. And these are a couple of things that I'm going to go over that will hopefully help you get it to do it. The main problem that I had was the full moon. The full moon obviously ravaged. I don't have my glasses on, I can't see. The full moon was, ravaging the process. And so I've got a gradient across all of my subs, and as the moon was getting lower in the atmosphere, there was more light dispersing, so my exposure is wildly different at the beginning of the session, at the end of the session, and you are not going to get Pixinsight to play with that data. That's just bad. But I figured out some steps that we can take to help Pixinsight deal with less than pristine data. And this is what you're going to have to do. You go, you take all your subs and you go and calibrate them normally. You do your, your bias frame, your darks, your flats. Calibrate all your frames normally. Debayer them if you need to. And then after debayering, this is what I did that helped Pixinsight to deal with this. Open up an image container. Put all of your subs into that image container. And then run. You've got your image container open. Then just make sure you can see that. Grab this icon in your image container and drop it on an automatic background extractor. And that will really knock down the gradient in your subs. And that'll go a long way in helping Pixinsight be able to make sense out of the data. And something that I needed to then go and do is after you extract all those, do your background extraction on all your subs, then you're going to go and take your image container again, get rid of all this junk, and then load up the subs that you just extracted the background from. And this is, we're going to open up Pixel Math here. And after you've got all of those subs that you just extracted your background, this is what you do. Now I'm not sure if this is going to degrade your data at all. It probably will. I'm sure it's doing something less than ideal. Nothing's perfect. But we're going to take the value, your pixel target value, and subtract your median times the value. And then we add a small, I picked this tip up from a guy in the forum. I forget his name. I'll write his name in the credits because this is a good tip. And then plus some small value, whatever you want your new median to be. And to keep it from clipping to 0. So you just write this equation in here, and you make it. You can replace target image, and then just have your target output. Have an output folder on your image container. Then replace target image, and then drag this to this, and it will execute this function on every pixel in that container, and that will even out your illumination across all of your subs, and that will also make your data easier for Pixinsight to handle when you go to subtract the Comet image. So calibrate your subs like normally, do a background extraction, automatic background extraction on all of your subs, and then you run this function on all of your subs, and after you do that, you can then go and start working on go ahead and do your normal star alignment. And when you do your star alignment, you want to pick a sub from the middle of your session, because you know, as your reference frame, right? You pick a sub from the middle of the session as your reference frame, because your comet's over here at the beginning of the session, it's over here at the end of the session. You know, pick the one where your comet's right in the middle, because if you use your first sub as your reference frame, then your frames are going to be trailing off to the side as you stack on them, and you know, you lose a lot of data in the out of that first frame. So you want your, you know, your middle frame to be your reference image. So you go ahead and do your normal star alignment on that, and then you load up the files that star alignment produces. You go ahead and load that up into your Comet alignment. And this next procedure is real simple. You load them all up, pick your output folder where you want all your Comet aligned images. What we're doing now is creating an image of the comet that you can then go and subtract from all of your subs. So you set your folder to where you want your comet aligned images to go, and then you hit show in parameters and click on where your comet is in your first one, and show and where your comet is in your second one, and that will allow Pixinsight to stack all of your subs on top of the comet. So that'll stack up all your comet. Make sure subtract is all blank and default. You don't want to subtract anything yet. And then just hit apply globally, and then you will have a nice comet stack. And where did my image integration go? So after you get your comet stack, you go into image integration. These are the settings that I used, and they worked for me. You don't want any normalization, because you've already, I'm pretty sure what that function did is it normalized it. I think, maybe, I don't know. But I use no normalization. Make sure your reference frame that you used for your initial star alignment, make sure that's set as your target. I don't think it's that vital in this step. It's just something anal. Because they're all stacked anyways, so you know, what does it matter? I don't think it matters. You know, it might matter in how much data you've got on the edges of your image. Okay, so anyways, no normalization. I tried average, and it didn't look as good. I had crap around the edges. I did a median, and it looked much better. With no normalization, the borders were a lot better. I left this all default. Pixel rejection, Sigma. Now I have a lot of subs because I was on that Comet for like 8 hours. Linear fit did not give me a very good result. Sigma clipping gave me a better result, even though I had so many subs. Scale plus 0 offset. Generate rejection maps, because I like to look at those. Clip low pixels, clip high pixels, and clip low range, because if you don't clip low range, you're going to have a huge black border around your comet image, and that is going to give Pixinsight fits too when it's trying to normalize things, or use linear fit if you use linear fit for the comet subtraction. Sigma high, turned it down to 2. That did a pretty good job. You can go and you can test this by just make a small little preview window around your stars that's going to have some, you know, interesting stuff in it on your subs, and then just run this integration on this region of interest, and it goes really fast if you just use a little preview to test it out. So I turned Sigma clipping low range. I turned it way down first, and then turned it up until it just started to nick into like the background. So when it was like at 1.8, it was just rejecting the stars, and then when I got it up to 2, it just started to nick into the background, and that's where I left it. Range low, keep it 0 so you get rid of those black borders around your subs. And that was my pixel rejection. Something that also helps immensely for getting rid of the stars is reject high large scale structures. That'll chop stars out like nobody's business. Left those set at 2. Now one thing I did, you'll notice, is I used every third sub for stacking my Comet image. If you don't have a lot of data, you're not going to have that luxury. Or if it's a very slow moving comet, it's not going to make any difference because the object is to isolate the star. So every third sub, the stars were far enough that they were completely isolated. Because if your stars are overlapping, it's going to be a lot harder for your integration to remove them. And you're still going to have some streaking, which you know you can probably remove without too much difficulty if you are better at Pixinsight than I am. With a lot more, with some masking and noise reduction and background reductions and things like the extractions. But anyways, so I already ran down the settings I used, and just integrate that, and then you will get a lovely, ideally, image of your comet, like this. So this is the isolated comet. You can see I've still got, you know, it wasn't perfect. This isn't the good one. Where did the good one go? I'm lost. Open Comet Master Median. That was the better one. Yeah, you can notice with all the same settings, average integration left all this junk around here, and median did, you know, just did a much nicer job. I don't know what the trade-off is. I don't know enough about Pixinsight or just image processing in general to know what we're missing. The Comet might be a little bit brighter in the average integration than it is in the median. I don't know. But anyways, the lack of the clipped out borders on the median integration made it so Pixinsight was happier with it when I was trying to subtract it from the subs. Now after you've got your comet image, now this is the part that will drive most people crazy if they don't know where to start. You leave all your same calibrated, background extracted, normalized subs. Leave those in your comet alignment, and you leave everything the same except you really don't leave anything the same. I don't know why I said that. So you set your output folder to where you want your stars to go, or your star aligned subs with the comet subtracted. You set that to where you want those to go. Your parameters will stay the same for now, but not for long. Then this is where we really change things up. You go to subtract, put the the integrated comet image you made from there. Linear fit has never worked for me. I don't know enough about linear fit. I'm sure you have to adjust these sliders to get it to do what you want it to do. Never worked for me. I always just turned that off, and because the data was so normalized to begin with, I don't think I needed it. So never needed linear fit. But yeah, just go ahead. I've got everything deselected and just a couple of them selected. Let me make sure I didn't click anything weird here. Yeah, I've got that selected, that comet selected, and you just run it, and there she goes. Now what it's doing is it's subtracting that comet image from your subs. Doesn't take too long without linear fit enabled. When linear fit is turned on, it takes a long time, but I never got it to work, so Don't need to turn it on. Okay, now it went and subtracted those files, or those comets, from our subs. We give them a stretch here, and wait a minute, that doesn't look right, does it? You know, I don't know why Pixinsight does this. It is so weird. Like, I didn't change anything. Wait, let me see if 747. I did change that. Let me change my reference frame. Yeah, make sure your reference frame and Comet alignment. I was playing with some stuff. Okay. Let me try that again. I was playing with some stuff because that was a lot farther out than it was before. But Pixinsight has never dropped that Comet right back down onto the old one, and I don't know why. It's always slightly off. So you've got to, and clicking around on it won't change it for some reason. I don't know why, but you have to manually go and put different numbers in here to get it to move. And let's see what that looked like. See, that's not bad. That's pretty close. Now, you know, your mileage may vary, but you can see it dropped that Comet a little bit in front of my original Comet. So what I do then is I go and just subtract, you know, maybe like 3 at a time. And then run it again. Because I've never seen it just smack dab right on the Comet. It's always a little bit messed up to begin with. And clicking around on the Comet doesn't change it for some reason. I think it's just the way when you click on it, Pixinsight runs some kind of algorithm and decides where the Comet is for you. It doesn't decide, it doesn't put it precisely where you drop that circle. But when you put those numbers in manually, I think that's got to be it. When you put them in manually, it changes where it puts the Comet. You can see it's a little bit closer now, so we'll drop it back maybe two or three more. So we'll go 237. The y-axis looks pretty good. So 237. Let's try 237. Big money, big money, big money. No whammies. That is starting to look pretty good. I think I could go back a fuzz more. But we're getting there. I mean, I'd even be happy with that. Like, that's not bad. That will be eliminated with integration. I mean, just the fact that all this big green glow is gone is a miracle in itself. But you can go and play with this. Let's try 235 and see how it looks. I'll leave the other one open so we can compare and contrast. But yeah, you can play with this number and get it to drop it right on that Comet, and it will really save you a lot of work in the post-processing realm. Yeah, I do the first one, the middle one, and the last one every time so I can see what it looks like and adjust from there. Now, how does that first sub look? Auto stretch. That's not bad. I'm happy with the first sub being there. That Comet is gonzo. So, first sub looks good. Let's see what the last sub in the sequence looks like. Last sub needs to drop back a little bit too. This is where the comet is in the last sub, and it's obviously dropping it in front of it. So open up comet alignment again, parameters. I subtracted. Let's subtract. Let's do. But anyways, you get the idea. You just play with this, get your comet to line up, and then as you saw with the first sub, it will do a really nice job subtracting it. And if you really want to get crazy, you can go and clone stamp over that little schmutz that's left over, and then you will get a really nice clean star field. And I'm gonna go ahead and go do all that, process everything, and get back with you. Okay, so after a little bit more trial and error, I think I figured out how the linear fit thing works. Because without it enabled, I was still having some problems. There was quite a bit of the comet left in the subs. Nothing that wouldn't have been difficult to remove, I don't think. But you know, I'm a perfectionist. So I played around with the linear fit a little bit more, and this is what the problem was. I mentioned earlier that it wasn't dropping, it wasn't actually lining the comet up, and I just realized that recently, right before I started shooting the video. After I turned the linear fit off, you could see it kind of gouged out in front of it, and I'm like, wait a minute, the comet isn't even exactly lined up. But anyways, if you enter these coordinates manually, run it, see where the comet is, tweak it, do that until you get them, you know, dead nut right over each other. Then you can use linear fit because they're actually lined up. And the way I set it up, you reject low just above your background. So my background is like, you know, it's all 0.1. So I set that to 0.1003, and then reject high just above the highest value on the core of your comet. And that's what I set things at. You know, left normalize on, and ran a few tests, and it really knocked down the comet. It looks great. So that's where a comet used to be. And this right here is nothing. That'll go away easily. The fact that this big green glow isn't here anymore is huge. So I'm going to go and integrate these subs. You know, I'm going to remove the comet from the rest of them, integrate them, and then I will show you the final result. I just want to look at this because it's so beautiful. There used to be a big comet there. You know, yeah, there's a little bit left, but that's good. You could probably tweak the settings a little more. You could probably get closer, but this is functional. Just having it to where it actually works is exciting for me. Alright, I'll be back in a bit. Okay, we're back after a little bit of work. You can see our integration here spit out a pretty clean star field. Tiny little bit of a glow there left from the comet, but otherwise pretty clean. Definitely a lot cleaner than the traditional ways of you know, usually you integrate a comet and then just make a star mask and copy and paste the stars over onto the comet. I don't really like that. I like integrating the star field from the data, integrating the comet from the data, and then combining the two. That feels a little more authentic to me than just copying and pasting a bunch of crap from the star field into the comet picture, which I mean that's a valid way of doing it. It just didn't feel right to me, and I wanted to get this Pixinsight method working, and I really feel like I got it working. Now I'm sure I can do it better. You know, I can integrate a cleaner comet image, and I know next to nothing, well, okay, basically nothing about post-processing in Pixinsight. Um, so I went and took both of these images into Photoshop and kind of did a quick once-over on them and got that out of them. Not too shabby, I don't think. But yeah, plenty of room for improvement. More of I just wanted to show everybody how to get Pixinsight to actually subtract the Comet from your subs, because I've seen a lot of people struggling with that. And hopefully this gives you a good base that you can work off of. Hopefully you know more about Pixinsight than I do and can do a better job than I did. But yeah, I'm gonna get back to the drawing board here, try to learn more about this software. Clear skies, and I will see you soon.